In this video, we're going to determine the isotope from the mass percent of the following subatomic particles. So let's say that we have an atomic mass that's equal to 112.41. Let's also say that we have the mass percents of each of our subatomic particles. So our mass percent of electrons is equal to 0.023%. The mass percent of our protons is equal to 43.01%. And our mass percent of neutrons is equal to 57.43%. With just these four pieces of information, we can determine our isotope, our nuclide symbol, just from this. So let's start with our neutrons. So we know that our mass percent of any of our subatomic particles, we'll just say n for this one, is going to be equal to our number of n times its mass of n, all divided by our atomic mass. And then all that times 100%. So from this, we can go backwards, fill in the information that we have, and we can solve for, importantly, this number of n. So let's start with our n, so our mass percent. Well, we know what our mass percent of n is. That is going to be equal to 57.43%. is equal to our number of n. I'm just going to call that n. We're going to multiply that by its mass, which we know is 1.0087. We're then going to divide that by our atomic mass, which we have, which is 112.41, and then multiply that by 100%. Now, first thing, I'm just going to get rid of that 100%. I'm going to move it over to the other side, which gives us our 0.5743 is then equal to our n times 1.0087, divide that by 112.41. Then just moving things over, for example, we'll multiply by 112.41, and then we'll divide by 1.0087. After we do that math, we will determine that our n is equal to 64. Next, let's do our protons. So we know our mass percent of our protons is equal to 43.01%, which is then equal to our number of protons, I'll call that P, times its mass, which is 1.0073, divide that by our total mass, which is 112.41, again, times 100%. So we'll move that over first, so we have our 0.4301 is equal to P times 1.0073, divide that by 112.41. Again, after some algebra, moving things over to isolate our p-value, we'll find that that is equal to 48. Now finally, our electrons. So our mass percent of our electrons is 0.023. So we'll go 0.023% is equal to our number of electrons, which we'll call E, multiplied by their mass, which is very, very small, 0.000549. Divided by our total mass, which is 112.41 times 100%. To get that 100% out of the way first, so this is going to be 0.00023 is equal to our number of electrons times their mass, 0.000549, all divided by our mass, which is 112.41. Again, after moving some numbers around, multiplying by 112.41 and then dividing by 0.000549, we'll find out that our electrons are equal to 47. Now we have enough information to determine our nuclide symbol. So since we know that our n is equal to 64, our p is equal to 48, and our electrons are equal to 47, we can start to fill out our information. So first off, we'll use our protons. We know that our protons is equal to our atomic number. So if we come up to our periodic table, we'll find 48, and that is equal to cadmium. So we know that this is going to be CD, and our lower number is going to be 48. Now to determine this upper number, the one that would go right here, we know that x is equal to our neutrons plus our protons. In other words, x is going to be equal to our 64 plus 48, which is equal to 112. So we will replace our x with 112. Now finally we need to determine if there is a charge on this one. So we look at our protons and our neutrons. So that's going to come right here. That's where our charge is going to be. So our y is going to be equal to our protons minus our electrons. So we see that y is going to be equal to 48 minus 47, which is equal to positive 1. So we will replace our protons with a positive 1. That will be our final answer.